Hi there, students. Let's get started with the greatest common factor and factoring by grouping. So this is chapter 5 now, and this is the first lesson in chapter 5. So 5.1. Get ready. You're about to learn how to factor. This is just the beginning. So we're going to classify numbers as prime or composite, factor out the greatest common factor, and factor a four-term polynomial using grouping. To factor means to write a quantity as a product. For example, if you have 6 times 2, 6 times 2 are considered to be the factors, and the product is considered to be 12, right? When we multiply the factors 6 and 2 together, we get the product 12. So again, that's when you're multiplying, and when we are factoring, we're breaking down the factors of 12. So 12 again is the product, but we're going to break it down into its factors 6 and 2. So that's an example. What's the difference between multiplying and factoring? Factoring is breaking down the numbers that are, when they are multiplied together, they give you the product. All right, let's move on. Other factor forms of 12 are the following. So you see this here, negative 6 times negative 2. So negative 6 and negative 2 are factors of 12. 3 and 4 are factors of 12. Why again? Because when you multiply those numbers together, you get the product 12. Negative 3 times 4, 12 times 1, for example. Negative 12 times negative 1 are also factors of positive 12. So more than 2 factors may be used. So another factor form of 12 is 2 times 2 times 3, because when you multiply those numbers together, you get 12. I'm hoping you get the point right now of why we call those numbers factors. So factors form a product when they are multiplied together. So the positive integer factors of 12 are 1, 2, 3, 4, 6, and 12, because all of these numbers can divide into 12. Let's talk about what a prime number is. Most people don't know that a prime number is a number greater than 1, not 1 itself, right? It's a number greater than 1 that is only divisible by itself in 1. What are some examples of prime numbers? So if 1 is not a prime number, then tell me in order, what are the prime numbers? So can you write down what you think the prime numbers are? If you began with 2, you are correct. 2 is a prime number because 2 can only be divided by itself in 1 evenly. Then you have 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on, etc., right? Because it keeps going on forever. A composite number is also a number greater than 1 that is not prime. So really, you can kind of look through these numbers right here. You can see that we can start with 4, for example, because again, is a number greater than 1. So 4, if you look in between these numbers, 6, all right, 8, 9, 10, 12, 14, 15, etc. Every composite number is the product of prime numbers. So we can break down composite numbers into prime numbers. That's all it's saying. So we're going to we're going to create some factorization trees, if you remember those from elementary school. So we're going to go and create these trees. Let's break down 16. For example, let's find 2 factors of 16. So give me 2 numbers that when you multiply them together, you will get 16. So you have a lot of choices, right? Let's go with 4 times 4. But if you broke down 8 times 2 or 1 or 8 times 2 or 4 times 4, you're still going to get the same answer in the end. Then we look at our branches, our leaves on our branches, and we decide whether or not those numbers are prime or not. These numbers are not prime numbers because we can break them down again. So we can break 4 down to 2 times 2. And again, 2 times 2. So what we're saying is that 16 is equal to 2 times 2 times 2 times 2. Those are prime numbers. So this is the prime factorization of 16. And of course, we can write that in a more concise way as 2 to the 4th power, since you understand exponents by now. All right, let's go to the next one, 63. What 2 numbers, if you multiply them together, will give you 63? Well, I'm going to choose 9 times 7. 9 times 7. And then we look at our 2 numbers. 7 is prime already, but we can break down 9 into 3 times 3. So 63 equals 3 times 3 times 7. So basically, the fruit that's hanging on the bottom fruit, those are the factors, right? So we have 3 squared times 7. 12 can be broken down in various ways, but you could choose, for example, you could choose 2 times 6 if you want to. You can choose 3 times 4. If we break that down, that 6 down, we get 2 and 3. So 12 equals 2 times 2 times 3, or you could write it as 2 squared times 3. And why don't you try 54? Break down 54 on your own. Pause the video and see what you get before you hear the answer. All right, so you can break down 54 as 9 times 6, for example, and 9 can be broken down as 3 times 3. 6 can also be broken down as 2 times 3. So 54, I'm going to write this decently in order, right? I'm going to write the 2 first. Then I'm going to put all the 3's together. So I wrote that. I'm putting that in numerical order. So this is the same thing as 2 times 3 cubed. Now let's talk about what the greatest common factor is. So that's what this entire lesson is all about. What is the greatest common factor? And we say GCF for short. It is the largest common factor. So when we look at 12 and we look at 63, what factor and what is the largest factor that is in common with 12 and 63? So if you look above here, we look up here, my highlighted. We look at the factors of 63 and we look at the factors of 12. What is in common with those 2 numbers? Well, see, 3 is in common. So, and that's the only thing that is in common. 3 is in common with both 12 and 63. So 3 is the greatest common factor of 12 and 63. Let's move on to 12 and 4. So I'm going to take these off. 12 and 4. So what do they have in common? Notice that we have for 12 and 4, and we highlight 12 and 4, we got a 2 here, we got a 2 here, we got a 2 here, we got a 2 here. So they have 2 2's in common. So 2 times 2. And what is 2 times 2? 4. 4 is the number that can divide into both 12 and 4, the largest number that can divide into 12 evenly, right? And to itself evenly. So, yes, 4 is the greatest common factor because 4 is the largest number that can divide into both 4 and 12 evenly. Now, let's review the distributive property for a second here because it's important that you understand the relationship between the distributive property and factoring. So, for example, A, we have 3 times x plus 2. Distributive property says that we're going to multiply what's on the outside of the parentheses times every term that's on the inside, starting with this x here. So 3 times x is 3x, and 3 times positive 2 will give us a positive 6. That's why we write plus 6. Moving on, we have 5 times 2x. So 5 times 2x is 10x, and 5 times negative 1 is negative 5. That's why we put minus 5. And then for C, we have x times x squared plus 6x minus 4. Now we're multiplying x times 3 different terms, starting with x squared. So that'll be x cubed, and then x times 6x would be 6x squared, and x times negative 4 would be negative 4x. So the relationship between distributive property and factoring is simple as this. Did you know that factoring is the reverse of the distributive property, right? So really, if we started with our results from the previous section, let's start with the answers, 3x plus 6, and let me show you how you factor from those particular results. So looking at 3x plus 6, first we identify how many terms are in this polynomial 3x plus 6. Well, we have 2 terms. So we're trying to figure out what is in common with these 2 terms. We have a 3x, we have a 6, a positive 6. What is in common with those 2 terms? Well, may not be so obvious, but 3 is the only thing that's in common with 3x and positive 6. So guess what? Since that's the only thing that's in common, that's the largest number that can divide into both, then 3 is our greatest common factor. Now, taking out the GCF is the very first step of factoring. Let me go ahead and point that out. Taking out the GCF is the very first step of factoring. So when I say complete, write the complete factorization, I always start with the GCF no matter what. Anytime you're factoring, start with the GCF. So we're going to rewrite the 3. We're going to put a parenthesis right next to it. And we decide what times 3 would give us the original first term, 3x. So what times 3 would give us 3x? Is it obvious? It should be. It's just x, right? 3 times x would give you 3x. All right, next we want to know 3 times what would give us the next term, positive 6. It will have to be a positive 2, right? So we have 3 times x plus 2. Always ensure that in the inside of this parenthesis that you still don't have something in common, right? X and 2 have nothing else in common. So you could be pretty confident that you are finished factoring at that point. But you always have to make sure that even inside that parenthesis, there's nothing else in common, right? And how do you check your factorization? Distributive property. Distributive property. All right, let's move on to the next one, 10x minus 5. Again, let me show you. These are just simply the reverse of these problems up here. All right, let's go on to 10x minus 5. Let's first identify how many terms we have. Again, we have two terms represented here. Two terms, 10x, and if you want to look at it as -5, what do they have in common? They have a 5 in common, right? So that is the greatest common factor because 5 is the only thing that's in common between the two terms. We write our 5 when we're factoring first. We put a parenthesis and decide what times 5 will give us 10x. What times 5 will give us 10x? It would be 2x, right? And always check as you're working this out. Don't try to do all the problem and not check as you go. Multiply that 5 times that 2x in your head before you move on to make sure you're getting 10x. Next, 5 times what? Next, 5 times what would give you the -5 back? It would have to be that -1. 5 times -1 will give you the -5 that you want. All right, moving on to the next one. We have x cubed plus 6x squared minus 4x. How many terms do we have? 3 terms. X cubed, 6x squared, -4x. And what is in common? There is only one x in common. Why is that? Some people don't understand that. So let me show you. If we have an x times x times x, and that is an x times x, and that is an x, what do they have in common? They only really have one x in common. They only have one x in common. If you look at all 3 at the same time, they don't have 2 in common because for x, the last term doesn't have enough x's to say that we have x squared in common. We don't have x cubed in common because, again, both of these 2 terms don't have enough to say we have x cubed in common. So there you go. X is what we have in common at that point. And that's the only thing we have in common because our coefficient for x cubed is considered to be what? All right, it's considered to be a 1 there. So only x is in common. So we rewrite our x and we're going to make our parentheses a little wider because we have 3 terms to put inside that parenthesis. So x times what will give you back the first term will be x squared plus what will give you back the middle term, that would be 6x, and then minus what will give you back that last one, it would be 4. Since we already have an x, times this will give you the -4x. Please do not put another x on that because you'll then have too many x's. All right, so if you check that by distributing, you will see that this is x cubed, the x cubed that we want. This will give us the 6x squared that we want. This will give us the -4x that we want. So always check your answer before proceeding. Again, factoring is the process of finding the individual factors of a product. Remember, the very first step of factoring is the GCF. All right, take out the GCF first every time. All right, let's practice on some of these. We have 9x squared minus 27x. What is in common? Well, what you could do, if you understand a little bit of what we've been doing, you can go ahead and pause the video now and then see how many of these that you can do. Okay, so I'm just going to go ahead and explain everything. But you can pause the video and attempt the problems yourself first. So we have what in common here. Always take out the greatest common factor first, which is, for this particular problem, what? 9x. 9x times what would give you 9x squared, x, and then what would give you minus 27x, minus 3. And we're just going to continue to proceed. Remember, you can always pause the video if you don't understand something and rewind and go back over and over and over again. All right, moving on. We have 3 terms here, and what you see, you have a 3, a 15, a 21. 3 is in common for that, but then you're also looking at your variables here. How many x's are in common among all terms? So we can only pull out x squared from all terms. So 3x squared times what will give you back this entire polynomial? X squared plus 5x minus 7. And always go back and multiply this in your head to ensure that you get 3x to the 4 plus 15x cubed minus 21x squared. Moving on to number 3, we have 3 terms. What's in common with all 3? A 9. When we pull out that 9, we have 9 times x squared plus 3x. Don't get caught up in this mistake. 9 times what will give you 9? You must put a constant there. So to ensure that when you multiply all of these things, you get this entire polynomial here. So always multiply to ensure you get back the entire polynomial. Moving on to number 4. Look at our coefficients first. We see we have an 8, a 2, a 12. Let's take out a 2, and we have an x cubed. We have an x to the 4th. We have just one x there. So notice we only take out the lowest number for the variables. And then we have also y's this time. Y squared, y, and y squared. So how many y's are we taking out? Only one y, because we only had one y here. All right, so for variables, we're actually taking out the lower of the variables, because that's the only thing we can take out, because that's the only variable that's in common with all 3 terms. Now, 2xy times what will give us this first term back, 8x cubed y squared. Well, I see that will be 4x squared y. Then we go to the middle, minus what? X cubed, because that x cubed and that x will give me that x to the 4th, but I have everything else I need, minus 6 to give me that 12. I already have an x, but I need one more y to multiply times that y to give us that last term. All right, moving on. Let's go to number 5, 8ab minus 18b. Well, we have a what in common here? Well, definitely we have, you want to, for whatever reason, I always want to take out a 4. That's not going to work. 4 is not going to work for 18, but 2 will. And also notice b is in common, right? So we have a b. So 2b times what? 4a minus 9 will give us what we need for that problem. Moving on, this is a different situation here. We have a negative in the front. Whenever there is a negative in the front, negative leading coefficient I think is an advantage for you to know how to also factor out that negative. So I know that we have a 3 and a w that's in common, but we're going to take out a negative 3w because it would be a little awkward if you didn't take out the negative in this case. I want you to learn that skill of factoring out the negative also along with the GCF. So negative 3W times a 3W will give us negative 9W squared. But this is the tricky part, because we took out the negative here and this is a positive. We also need a minus here, so that when we multiply these two things together, we get the identical sign in the original polynomial. So negative 3W times 3W minus what? Well, that would have to be a 2. All right. And again, I did this because the polynomial started with a negative leading coefficient. That's the first thing we saw in that polynomial. Moving on, we have 12x cubed plus 16x squared, which has 4x squared in common. We take that out. 4x squared times what? It would have to be a 3 to give us that 12, and an x plus 4 times what? That we have to be a 4. And we already have the x squared, so we don't have to put anything else there. All right, let's talk about common binomial factors. This is a little different, but here's what I want you to notice. I want you to look at this as 1 unit, and I want you to look at this as 1 unit, and tell me between what's green and blue, what do you see in there that's identical? Well, you should see that b plus 1 is identical. So that is considered to be your GCF. Since it's a binomial, we're going to put a parenthesis around it, right? But again, this is like your GCF. We always take it out first. Take GCF out first. And we usually write it down first, right? We write it down first and we decide what times that GCF will give us back, for example, the green part. So what times b plus 1 will give us a squared times b plus 1? Well, we only have to be a squared because we have the b plus 1. B plus 1 times a squared is the same as a squared times b plus 1. Let me say that again. B plus 1 times a squared is the same thing as a squared times b plus 1. Also, b plus 1 times what? Well, it would have to be plus 2, right? Because b plus 1 times 2 would give us 2 times b plus 1. It's as simple as that. So yeah, I wrote a lot of stuff around here, and I have a lot of little arcs, and I have a lot of highlights, but the final answer was as simple as b plus 1 times a squared plus 2. Let's look at the next one. So again, if I highlighted this as a color and I highlighted the second part as a color, what do you see between the two colors that is identical? Well, I'm hoping you see that 2y minus 1 is identical. It's the only thing that they have in common. We're going to call it our greatest binomial factor. So take that out. We put a parenthesis around the binomial as well as right next to the binomial, and we decide 2y minus 1 times what will give us back this blue part. It would just be x, and then it would just be minus y for the second part. And that is your final answer. Moving on to the next problem, we have a times a minus b plus 5 times b minus a. This one is different. I want you to notice that what you see here is not what you see here. They are not the same. because this is A minus B, this is B minus A, the signs are definitely not the same. A is positive here, right? And but here A is negative, for example. So they are not identical. But we can do a little manipulating, right? To make it happen. So this is the same as A times A minus B. I'm just rewriting the first part. But would you agree that B minus A is the same as negative A plus B? If I put that in reverse order, wouldn't it be negative A plus B? Yes, and let's put this out here. That negative A plus B. Let's say I said, class, factor out a negative 1. Just like that problem. That's why I wanted you to learn that skill. Okay? Just like this problem right here. So let's factor out negative. It's the reason why I asked you to do that, because this is going to come in handy. And especially with problems like this, that you know how to factor out a negative 1. So if we factor out a negative 1 here, we will get A what? Minus B. This is exactly what we want. We want A minus B, right? So what I'm going to do is rewrite this problem as A times A minus B. But on this side, 5 times negative 1 times A minus B. Because that's what it's equivalent to, right? So this negative A plus B is the same as negative 1 times A minus B, according to this over here. Because we just factor out a negative 1, and this means the same as negative A plus B, right? So what I did was switch them out. Instead of writing negative A plus B back over, I wrote negative 1 times A minus B because they are the same. Now what is this? This is the same as A times A minus B NF to negative 5. And then you have A minus B. And now we're at a point where we have what we want. We have A minus B and we have A minus B. So they're the same. And now we can go ahead and factor out our greatest common binomial factor. So our final answer, once we take out A minus B, then we have A minus 5, and that is the final answer. So that's perhaps one of the harder problems that you encounter when you are factoring out common binomial factors. So that leads us to something called factoring by grouping, which is a method used primarily when you have four terms. And you all know how to identify how many terms you have by now. So this should be pretty simple. When you have 4 terms, factoring by grouping is probably going to be the method you're going to end up using after you look for the GCF first. For example, you have 4 terms for A, B squared, 4B squared, 3A, and 12, right? You have these terms and they have nothing in common, right? All 4 at the same time. So this is when you decide, okay, there's no greatest common factor for all 4 terms, but these 2 have something in common and these 2 terms have something in common. So what you should do is take out what's in common with each group. Let's call this group 1, the first group, and this is group 2. So what does group 1 have in common? It has a B squared in common. We'll take that out. And what will be left over? We have an A minus 4. And then the next one, what you have in common is a positive 3. So make sure you put a sign here. It's one of my pet peeves when students don't put their signs in the problem. I never understood why you wouldn't put signs there. Because then how would we know it's a positive or a negative if you don't put that there? So we're going to put a positive for this one because we have positive 3a minus 12, and what we want is just a minus 4, and we want that because it showed up over here, and then we have another a minus 4, so this works out. Our answer is a minus 4, right? We're taking what we learned from the last section, and then we're finishing b squared plus 3. So our final answer is a minus 4 times b squared plus 3 for the first problem, factoring by grouping problem. Next, we have x squared plus 2x minus 3x minus 6. Again, no GCF for all 4 terms, but since there are 4 terms, we could see if we have something that we can take out for the first, and we do. X is in common, times x plus 2. And what we want to happen over to the right is to get x plus 2, right? And so in order for that to happen, to get x plus 2, we need to take out a minus or a negative 3, right? Because then that will flip our sign to x plus 2 here, and that's what we want. We want these two parentheses to match. If they don't match, we cannot proceed to the next step, and we need to proceed to the next step. So our final answer is x plus 2 times x minus 3. Moving on to the next one, we have x cubed minus 8x squared minus 2x plus 16. And let me just also say this, and I did not mention this, but you could always rearrange terms if, for example, if necessary. Let me see. Because sometimes, for example, you may find that your first term, let's just say x cubed, has nothing in common, and it was right next to 16, for example. Let's just say, let me rewrite it. It was x cubed plus 16 minus 8x squared minus 2x. What if this was written this way? Then x cubed and 16 have nothing in common. You see what I mean? But in that case, you can always rearrange your terms so that x cubed is next to something that it has in common, like this, right? So you can always change terms around, remembering that whenever you move things around, you have to maintain the sign that's in front of each term, okay? You can't move it and change the sign. It has to be the same sign. All right, moving on, we're going to now group. So what's in common with our first group here? Well, it looks like to me we have x squared in common. When we pull that out, we will have an x minus 8. And then we have negative 2x plus 16. We want to get back, we want x minus 8 to show up over here somewhere. So what would you have to factor out of negative 2x plus 16 so that you would get a factor x minus 8? You would have to take out a negative 2 to get that x minus 8. Because negative 2 times x minus 8 is negative 2x plus 16. So the final answer is x minus 8 times x squared minus 2. Alright, next we have 2xy plus 3y plus 2x plus 3. Let's look at this one. We definitely have a y in common, so that's 2x plus 3. And notice we already have a 2x plus 3 over here, but we have to take a number out. We have to have some type of factored out number there. So what would make sense to take out and put here? And we're not altering the problem. It means exactly the same as 2x plus 3. Well, you can only put a plus 1 there times 2x plus 3, right? Because 1 times 2x plus 3 is 2x plus 3. So the final answer is 2x plus 3 times, then you have your y plus 1. Again, you could always check this by multiplying or foiling this all the way out to see if you get back the original. Alright, 2 more problems. We have E here. Take out a 2x squared times x plus 9. And again, what do we need to take out so that we get x plus 9 as a factor on the right side? We have to take out a negative 1. And then multiplying that times x plus 9 will give us that negative x minus 9. So our final answer is x plus 9 times 2x squared minus 1. And I also forgot to mention, for all of these problems for the factoring by grouping, that multiplication is commutative. So I just wrote this as x plus 9 times 2x squared minus 1. But I'm hoping that you already know that that is the same as 2x squared minus 1 times x plus 9. So for all of those previous problems, you don't have to write 2x plus 3 times y plus 1 to be right. If you wrote, for example, y plus 1 times 2x plus 3, you are also correct.